Chaz here at the top of Mount Yona. I'm going to stay off the video on this one so that you guys can just see the view that I'm getting to see right now at the top of the mountain. This is lesson 2B-4, Solving by Elimination. You'll also hear this method called solving by combination sometimes. This is another method that we can use in addition to graphing and substitution, and this method is going to complete our repertoire of 3 different ways that we are able to solve systems of equation. After this lesson, you guys will kind of have to decide based on which setup you see your systems in as to which is going to be the most advantageous for you to use. We honestly don't care which one you use as long as you are getting the correct answer. So without any further introduction, let's go ahead and jump into the video for solving systems by elimination. See you guys soon.
Alright, we've already been working on solving systems of equations. So far we've talked about 2 different methods, solving by graphing and solving by substitution. Today we're going to look at a third method, solving by elimination. Now, we know that in a regular, simple, linear equation, back before we were doing systems and doing more than one equation at a time, when we had an equation like 3x plus 5 equals 10, we knew that we could add or subtract the same quantity on both sides to preserve the equality. We can do the same thing with multiplication or division. These ideas, called the properties of equality, can help you develop another method for solving systems of equations. This method is going to involve combining separate linear equations using those 4 basic operations, addition, subtraction, multiplication, and division, into one equation with only one variable. So the reason we call it elimination is that we're trying to go from a system that has 2 variables in it to an equation that only has 1 variable that we can solve for. So before we do some concrete examples, we want to go ahead and do a proof and kind of demonstrate to you guys why the elimination method works. Now it might be a little bit confusing at first, so feel free to rewind this and replay it as much as you need to. But we're going to go through a simple proof, and then I'm going to work 2 examples that will show you using the method directly without the proof setup. So we're given this system of equations, x plus y equals 3 and x minus y equals negative 9. Now, remember, our goal is to try and eliminate or cancel out one of the variables so that we only end up with 1. So I'm going to try something here. I'm going to take my first equation, x plus y equals 3, and I'm going to try and add x minus y to both sides. So I'm going to write the original x plus y from here, and then I'm going to take the x minus y from here, and I'm going to add that to the left side of the equation. Now remember, with my properties of equality, whatever I do to one side, I have to do to the other. So I still have my 3 on my original equality, and I'm going to add the x plus y, or sorry, the x minus y to this side as well. Now, the reasoning and the justification that allows me to do that is the addition property of equality. The addition property of equality. Remember back from when we were doing proofs and solving systems, that was what told me if I add one thing to one side and add the same thing to the other side, then I would still have the same equation. It doesn't change anything since I add the same thing to both sides. Now, on this side, we're going to be able to combine some like terms. On this side, we don't have any like terms, though, and I want to change that a little bit before I work with this any further. So, drawing back on my substitution, I know that x minus y is also equal to negative 9. So what I want to do, since I just have a constant on this side, is I want to replace this x minus y with the negative 9 here. So I'm going to rewrite my first equation, or the first side of the equation, exactly as I have it. X plus y plus x minus y equals 3. But now I'm going to replace this x minus y with the negative 9 up here. Alright, and the thing that allows me to do that is my substitution property. I can take 2 things that are equal to each other and swap them out. We knew that this x minus y was equal to negative 9, so we can replace that because it's a little bit more convenient to work. Now, I'm set up where I have like terms on this side and I have like terms on this side. So I want to go ahead and combine them. Alright, so I'm going to combine my x and my x, and that's going to give me my 2x. Now, when I take a positive y and a negative y and add them together, that's going to give me 0. And technically it's 0y, but that means that we're going to multiply y times 0, which just gives us 0. And on the right we're going to have 3 minus 9, which is negative 6. Alright, so the thing that allowed us to do that, where we added the y plus the negative y, if you remember back to our properties, was the additive inverse. That tells me if I take a number and I add its opposite, it's going to give me 0. So simplifying and using the additive identity, remember the additive identity tells me that anything plus 0 is going to equal itself. This gives me 2x equals negative 6. Now I'm going to have to divide both sides by 2, and that's going to give me x equals negative 3. And I use the division property of equality. Alright, so now remember, if we wanted to find the y value outside of our proof, we would have to go plug this back in into either of the top equations. So I'm just going to plug it into the top one. X plus y equals 3. That's just my equation from the top. I now know that x is negative 3 plus y equals 3. So I would add 3 to both sides and get y equals 6 for the ordered pair negative 3, positive 6. So again, just to recap on why we call this the elimination method, when we combine our like terms, we eliminate one of our variables and we get it down to just one variable for us to solve. Alright, so let's go ahead and take a look at some examples that we can work without having to give all these proofs. We just wanted you guys to see the justification and the proof as to why this method works. So we have 6x plus 3y equals 0, and we have negative 3x plus 3y equals 9. Now, we want to look for a way to be able to combine these. Alright, now, if I were to just add these equations, they would not give me anything to cancel out. So what I want to be able to do is I want to figure out a way to manipulate this equation using my 4 operations to make it so that one of these variables cancel out. Now if you remember from our proof, the way that things canceled out is when we were adding a positive number to the same number that just had a negative sign in front of it. So I'm going to look at these. My 3 y's are pretty close to each other. The only difference is that they're both positive, unlike in the other example where one was positive and one was negative. So what we are going to do is we're going to take one of these equations, and it doesn't matter which one. Now I'm just going to multiply this by a negative 1 to change the equation. So my first equation I'm going to leave the same. 6x plus 3y equals 0. Then I'm multiplying that bottom equation by negative 1. So a negative 1 times a negative 3x is going to give me a positive 3x. And a negative 1 times a positive 3y is going to give me a negative 3y. And a negative 1 times 9 is negative 9. Now, we're going to use addition to combine these. We're basically doing the same thing we did over here. We're just doing it in a few less steps and without the justification of the proof. So I'm going to combine my like terms going down. 6x and 3x is 9x. Now a 3y and a negative 3y are going to cancel out. They're going to give me 0. And a 0 minus 9 is equal to negative 9. Alright, so we would divide both sides by 9, and we get x equals negative 1. Now, we want to go back and plug in and figure out what y is. So we would plug in 6 times negative 1 plus 3y equals 0. 6 times negative 1 is going to be negative 6 plus 3y equals 0. We want to add 6 to both sides to get the y by itself, so we get 3y equals 6. We're multiplying y times 3, so we want to divide both sides by 3, do the inverse. So y is equal to 2, giving us the ordered pair negative 1, positive 2. Alright, so just to recap, we wanted these to be where we had the same number in front of the variable but opposite signs. In this case, we already had 3's in front of the y's, but what we had both were positive. To be able to change that, we multiplied the whole equation by negative 1. Now, you can't just pick and choose. You have to distribute the negative 1 through all three parts. One mistake people will make is they'll change the sign on that 3y, but they won't change the sign on everything else. You have to multiply it through the whole equation. Alright, let's do one more example together. Alright, so we have 2x plus y equals 60 and x plus 2y equals 75. Now if you notice this time in our x's, we have a 2x and an x, and then we have in our y's a y and a 2y. Neither of those have the same numbers in front yet. But we can multiply one of these to give us the same number just like we did before. Now we can do elimination in a couple different ways. I'm going to go ahead in this case just to show you that since in the last one we multiplied the bottom one, on this one we can multiply the top one. I'm going to multiply this top by a number that's going to let me cancel out the y's here. Now I have a 2y here, so I'm going to ask myself what times y is going to give me 2y. Now that answer is 2. Now, this is a positive 2y down here, and I have a positive y here. So instead of just multiplying by a positive 2, I need to also stick a negative sign in front of that so that I'm able to make that cancel. So I'm going to leave this equation the same. I'm going to multiply negative 2 times 2x, which is going to give me negative 4x. I'm going to multiply negative 2 times y and get negative 2y. And 60 times negative 2 is negative 120. So I am going to combine my like terms, and x and negative 4x is a negative 3x. My 2y and my negative 2y are going to cancel with each other. And my negative 120 and my 75 are going to combine to give me negative 45. I divide both sides by negative 3. And I get x equals, let's see, positive 15. Plug that back in. 2 times 15 plus y equals 60. 2 times 15 is 30 plus y equals 60. Subtract 30 from both sides, so y is equal to 30. So, our ordered pair then would be 15, 30. Now just to show that this can be worked in more than one way, I'm going to work this problem one more time. I'm going to have 2x plus y equals 60 still. I'm going to have x plus 2y equals 75. This time, I'm going to multiply the bottom. Now, in this time, it's going to be tough to make a 2y match a 1y, but I can make the x match the 2x. So I'm going to multiply the bottom by 2 this time. And since this is positive up here, I want to do a negative down here. So my top equation is still going to be 2x plus y equals 60. But my bottom one is going to change to negative 2x minus 4y equals negative 150. I'm going to combine like terms here. My x's will cancel. I will get a negative 3y, and I will get a negative 90 here. I would divide both sides by -3, and I would get y is equal to 30. Notice that that is exactly what we got over here. Now if we plug that into our original equation, and we can plug into either one, x plus 2y, which y is 30, equals 75. X plus 60, 2 times 30 is 60. X plus 60 equals 75. We subtract 60 from both sides, and we get x equals 15. Notice that's the same thing we got here. Alright, so make sure you complete practice 2B-4 and then pick up application 2B-4 from the Algebra Embassy. Make sure you're completing that application before you move on to the mastery check. Before I turn you loose, I do want to just go back and revisit one thing from our first example. If you remember, our first example was x plus y equals 3 and x minus y equals -9. Remember, that is the example that we did the proof for. I just wanted to show you real quick, without all the fanciness and elaboration that goes with the proof. Sometimes you will see that your numbers can already combine without you having to multiply anything. In this case, we had the positive y and we have the negative y. We could have gone ahead and combined the terms as is. So we could have done x plus x is 2x, and y minus y would cancel. And on the other side, we would have 3 minus 9, which would be -6. And we could go ahead solving the problem like that. I just wanted to go back and reiterate that sometimes you might not have to multiply either one. Sometimes they might be already set up for you to go ahead and combine. If you do not have the same number with opposite signs match up, then you will need to go back, like in example 2, and multiply it either by a negative, or in problem number 3, where we actually had to multiply by another number. I just wanted to clear up any confusion that you might have had if it was already set up for you. When you're asking what do I multiply by, you can see that sometimes it will already go ahead and cancel for you. Alright, with that I will go ahead and turn you loose on the practice. Make sure you let us know if you need any help, and we'll see you in the next lesson, the last video of the unit. Alright, see you then.